Okay, so let's move on to the second part of the challenge problem for chapter 6. So we have a show on the right. So this is the angle C is trisect. So it's still 30, 30, and 30, right? And E is on the AB, F is on the AD, so BE is 6 and AF is 2. Okay, so triangle the ECD is the 30, 60, 90, right? So you know it's 6, so that's why it's 6 root of 6 root 3, and this is the 12. Okay, 6 root 3, so you can see this one is 6 root 3 and minus 2, right? So then triangle the FDC is 30, 60, 90, right? So you can also getting this one, CD is root 3, that's 6 root 3 minus 2, right? So now you find the BC, find the DF, and you can also find the area, right? So A, B, C, D is equal to root 3, 6 root 3 minus 2 times 6 root 3. Next. So initially, a 50 foot ladder rests against a wall. Okay. As I started to climb it, the ladder slide down. So at the beginning is this. It's A, B, O, right? It's sliding to down and finally stop that it touched the wall at 6 feet below where it's original. This is original. Then this is the after, right? It's the C and the D. And E. So you know this is 8. What's the other? Slide 16 feet from the original positions. This is the 16. Okay, so AC equals 8, then BE equals 16, and you know the AB equals CE because the length of the ladder doesn't change, right? Equals 50. So the question is asking you how far is from the top the ladder from the ground after the slide. Okay, so the question is asking you how long is this Y. Okay, so this problem there are you can basically set this one to x, right? And we can set two equations, right? So the x squared plus the y plus 8 square is equal to 50 square, right? And the x plus 16 square plus the y square is also equal to 50 square. So we can solve this equation, okay? Now let's do it using the 2 minus 1. What do we have? We have the minus 8, then 2y plus 8. So now we can see the 8 is 2x plus the 16 minus y minus 4. So y equal 2x plus the 12. Okay, so now you need to apply this one to any one of them. Okay, so that we have the x plus the x squared plus excuse me. Okay, we can go solve this. Okay, then this is still a quadratic equation, right? Then you can see x equal to 14. Okay, then once x equal to 14, we solve the y equals 2 times 14 plus 12. Okay. Next. So using only pencil and paper, okay, find the Pythagorean triples with 73 as the length of the hypotenuse. So we want to find the a squared plus b squared equals to 73 squared. So Pythagorean triple have the still very similar to 97, right? This significantly reduced the range, right? From the 70 square reduced to 73. Okay. Now without loss of generality, see this, then we can put something. One square 72. What is the 2 square 69? 3 square 64. The 4 square 57. The 5 square 48. And the 6 square 37. Okay, so you check this one, right? Now we find the Pythagorean theorem, Pythagorean triples. So it's we must have the 73 and the 64 minus 9. What is the 64 minus 9 is 55. Then 2 times 3 times 8, 48. Okay, next. So if the leg of the three sides of a right triangle are whole numbers, how many such distinct non-congruent right triangles exist to have one leg with the length of the 24? Okay, so one leg is 24, and we have the the other ones, say A and C. So we have the C square minus A square is equal to the 24 square. Then we have the C minus A C plus A is equal to the 24 square. Right, is same way. Okay. Okay. So 124 square, 288, 3, 192, 4, 144, 6, 96, 8, 72, 9, 64, 12, 48, 16, 36, okay. Now we can see which is the integer. No, no. Okay. Now we can basically after this you already know, right? 1, 2, 3, 4, 5, 6, 7. I'm sorry, this one. So 1, 2, 3, 4, 5, 6, 7. Next, so we have a triangle. (13, 14, 15). Find the length of the R to the ST of the height. We want to know this, right? Okay, so if you remember the Heron's formula, Heron's formula tells us if we know the three sides, right, the triangle is equal to S minus A, S minus B, S minus C. The A, B, C are the three sides, and the S equal to A plus B plus C divided by 2, right? So here we know the three sides, so let's see, S equal to S minus A, S minus B, S minus C, it doesn't matter because they are cyclic. Okay, so that's why equals to 21, 7 times 6 times 8 is equal to 84. Okay, then you can solve this h. So half of the 14 times h is equal to 84. So h is equal to 12. Okay. So next, if M is the midpoint of ST, what is the RM? Okay, so take a Pythagorean theorem, right? So of the RSD, okay? So triangle RSD, Okay, Pythagorean. So we know the 13 and 12. So SD is equal to 5. If SD equal to 5, right, this half is length is 7, so we know the MD is equal to 2. If MD equals to 2, H is 12, right? So we know the RM is equal to 144 plus 4 is 148 is equal to next. Okay. Still remember I talked this they talk about the perimeter of this type of problem. I think it's on chapter 2, very beginning, right? I said there is called a fractional中文叫分形几何 OK This 分形几何 or the fractional geometry means you can repeat a pattern, and the goal is the result is the conclusion. The conclusion is area is limited. Okay, perimeter can approach to infinity. Okay, so that's why this in our human body, and we have the cells, right? We have a set of the cells, and we have the DNA string. Okay, so the DNA string is very, very long, very, very long, but they are limited in stays inside a limited spacing cell. So this is basically per investigation, they see the DNA is the structure is like the fractional geometry. Okay. Now let's see. Last time we show all the perimeter approaching to the is unbounded, right? And today we are going to show its area is limited. Okay. Now let's do it. So we are going to find a recursion. Okay, so we are going to find, for example, the first one. Let's list something. This is the first one. Okay, the side length. Okay, the first one, the side length is 1, right? So the number of new triangles called the number of delta of the new, right? This is only 1. And so the number of area of delta area of the new area, right? So let's find the recursion. Okay, so the first one is the root 3 over 4, right? Times 1 square. So this is the first one. The second one, you can see its side has been broken into 3 parts, right? So either these 2 parts becomes 1 over 3, and the original of the original, we have the 3 sides, right? So you can see on each side there is additional small equilateral. So that's why we have 3 additional of the equilateral triangle. So number of small is 3, right? So now you can see is the root 3 of each one is 1 over 3 of the square, and times the we have the we have the additional is 3. now we comes to this figure, right? So you can see it's now we can see this, right? So the side length is become 1 over 9, right? Is 1 over 3 over square, right? So, and you can see how many sides we have, right? So for this one, right? So for each one side, we already become 4 side, right? We already become 4 side. See, this one side already becomes the 1, 2, 3, 4, right? So that's why we have the 3 sides, each one is 4, so 3 times 4, we already broken into 12 sides. And for this one, see, each new side is getting a new one, right? So we have this amount of the new triangles. So it's the root 3 over 4 and 1 over 3 square of the square times 3 times 4, right? Now for the 4, okay? Still, each side is broken into the 4 sides, right? So 3 times 4 times 4, okay? So this is the number of the new triangles we add, right? And this one is broken into, again, 1/3, okay? So the new area is so on and so forth, okay? Now let's add all this together, right? So we have a pattern, okay? So we see a pattern, right? So now let's see, is the root 3 over 4, right? Did you see we have 4 here, right? So means the first 2 is not a pattern. Starting from the 3, 4, we kind of have a pattern, okay? So plus, let's see, this is root 3 over 4 times 1 over 3. Then next is, let's take out the common term, is the root 3 over 4. And we have the 3/4 is 3 over 4 plus this is the 3/6, right? 6 is 5, the 4 square. Next term is 4/3 of the 3 to the 7th plus forever. Now let's solve this geometric sequence, right? So s equal to the 4 over 3/3 plus 4 square 3/5 plus 4 to the 3 and 3 to the 7 plus. Okay, now let's times the, so 3 square, right, times the 4s is equal to the 4 square 3/5 plus the 4 cube 3 to the 7 plus forever. So now we have the 1 and 2. So the 1 minus 2, we have the 1 minus 4 over 9 of the s equal to the 4 over the 27. So we know the s equal 5 3 over 4, 4 over this is 4 over 15. Okay, now we solve the s, right? So this part is s. Now let's put them in. So for this part is the square root of 4 times 3/4 plus root 3 over 4 times the 15 over 4. So we have the root of the 3 plus root 3 to the 15 is 15 over 5 is 15 over 6 root 3 is 5 of the 2 root 3. See? So you can see when you approach to infinity of this type of the pattern, your area is bounded, but your perimeter goes to infinity. Okay. Yeah, this is the very, very significant, important conclusions from the fractional geometry. Next is the XOY. This is the right triangle. M and N be the midpoint. On leg OX and OY respectively. Now we have the XN is 19 and the YM is 22. So we want to find XY, okay? Let's parameterize it. So let's say A, B, B, and C, right? So C square is 4A square plus the 4B square is 4 times A square plus the B square. Okay, in order to find the C, so we have two right triangle we can use. Okay, right, we have the triangle XON. We have the 4A square plus the B square equal to the 19 square, and the triangle MOY is the 4B square plus A square equals to 22 square. 2. Then we have the 1 plus 2. We could have the 5A square plus B square is equal to the 19 square, 22 square. Right, is equal to 845. Then we know that A square plus B square is equals to 169. So that A square plus B square, the root is 13, right? Then we can see the C is equal to 2 times the root of A square plus the B square is equal to 26. Next, so in triangle ABC, we have an isosceles triangle. The A, B, and the C is root minus 1 is 30. If this is the 30, we can calculate it. This is 75 and this is the 75. Okay, so we want to find the length of the AB. Okay, so if you know the trigonometry, okay, if you learn the trig, okay, basically it's very simple. It's we under the law of sine, we know that BC over sine 30 is equal to the AB of sine 75. Okay, and the sine 75 is the 6 plus root 2 divided by 4, and the sine 30 is equal to the 1/2. And also you know the BC is root 3 minus 1. You can solve in this way. Okay, this is the approach one. But this one, we haven't learned the trick before, right? So normally when you see this, when you see the isosceles triangle, we always land the height, because the height is the angle bisector. and also the midpoint, and also this, right? And this is a 15, so normally we do this, okay? So in this case, we can converting the side, okay? We can converting the sides from this one to the other side. So now you can see we want if we know the height of AD, right? So if we know AD, right, we can apply Pythagorean right triangle ABD, right? So now let's see. So if we put a 60 degrees and 15 degrees, so this is the 60 and the 15, right? So this is the P, the BPC, okay? So we construct a equilateral triangle BPC, right? So we know the BP, we know the AP, right? We construct the BPC, so we know the sides. This one is the √3 minus 1, this is the √3 minus 1, right? But we also know this is the 15 degrees, and this is the 15 degrees. Okay, so we know the triangle BPC, we construct equilateral. Then, so we can know, now we know the BPA and triangle CPA are congruent, and also isosceles triangle. Okay, if they are isosceles, you know this is the √3 minus 1, right? And then you know this is the height. The PD is the height, right? So now we know the AP equal to √3 minus 1, right? And we know the PD is √3 over 2, √3 minus 1. Okay, now we add together, we know the AD is equal to the 2 plus √3. Okay, now you know the AD, right? We know the AD, we know the BD. Now we know the AB, right? Now we know the AB square is equal to the AD square plus the BD square is equal to, right? So we can convert in this one to here. So it's 2 plus square root of 3 of square and 2 plus 1, right? So finally you can see is equal to 2. Then AB is okay. Next. Yeah, so this one is not difficult. ABBC. Let's see, A, okay. It says this is the 30 degrees. So you can do this, right? So the triangle ABD is a 30, 60, 90, right? So you know this one's 3, this is 3 √3. So this one is 8 minus 3 √3, okay? Now you can apply the AC square is equal to the AD square plus the CD square is equal to okay, that's the first one. Second one, no difference. So this is the 45. You do this, right? So triangle ABD is 45, 45, 90. Right, so this is the 45. So you know is the 6 and 8. So this 3 root 2 and 3 root 2. The 8 minus 3 root 2. Right, so again apply the AC square is AD square plus the CD square. Last one is 135. Then the height is here. 45, 45, 6 is here, 8 is here. Here is the D, right? So 6, 45, 45, 3 root 2, 3 root 2. Then you have the AC square is equal to AD square plus the DC square is equal to 3 root 2 square plus the 8 plus 3 root 2 square. Okay, so that's it for the challenge problem of the chapter 6. Thank you.